Hello everyone, my name is Roland. Our project name is Nanotechnologies for Biosensors. Currently, the PCR technology remains to be the gold standard in DNA diagnosis, which provides high sensitivity and specificity. The biggest feature of PCR is that it could greatly increase the amount of DNA. There are three steps of PCR, including denaturing stage, annealing stage, and extending stage. Denaturing stage is to raise the temperature to separate the double strands. Annealing is to cool the reaction so the primers can bond their complementary sequences on the single-strand template. Extension is about to make new DNA strands by repeating this process for 20 to 40 times. The DNA could be amplified. The RPA is an isothermal single-tube alternative to PCR. When an RPA method is supplemented with a reverse transcriptase enzyme, it could detect both RNA and DNA, removing the need for a separate cDNA synthesis step. Because RPA is isothermal, it requires significantly less equipment than PCR, which requires a heat cycle. RPA reaction can theoretically be conducted quickly by holding a tube at 33 to 42 degrees and continue to work at room temperature, although more slowly. Because of this, RPA is a strong competitor for developing low-cost, fast point-of-care molecular testing. Bacteria is lysed and release their DNA. RPA could be used to amplify the DNA, which means increasing the amount of DNA. When combined with the CRISPR detection method, the qualitative results could be observed by a naked eye on the flashlight. In this case, RPA could be used for lowering the detection limit.
Hi, I'm Yu Chen, and a variety of plasmonic-based devices have been proposed in the past. Generally speaking, plasmonic systems are known for their versatility, modularity, and rapid detection. Typically, the structures of the devices consist of a dielectric or metallic film with artificial nanostructures at the subwavelength thickness. The working mechanism is based on the coupling of external excitations and electromagnetic oscillations near the surface of the previous mentioned structures. Plasma etch is one of the common methods to manufacture such devices. For example, RE or DRIE process. The proposed plasmonic chip could be further modified by additional conjugations with aptamers or recognition elements for the different bio applications. And so how did we produce the structures? Here we showed a few examples about our previous work. From left to right, the periodic structures were processed under different time periods. And this shows you the idea how the devices could be during the operations. Here we are looking into a plasmonic device consisting of gold nanomaterial-like structures on glass substrate. Some gold nanoparticles were randomly added on the surface to study characteristic absorption spectrum. We built a spectral photometer consisting of a halogen light source, filters, and a spectrometer. The wavelength shift was defined as the difference of average peak wavelengths from measurements taken and before and after the experiment. And we developed a micro device called an impact chip that enables us to perform viral detection on the solid surface of PDMS micropillars. Left is the SEM image of micropillars that we fabricated via photolithography and soft lithography. The diameter of each micropillars is 100 micrometers. We're hoping that micropillar structures will enhance biomolecular binding capacity compared to planar surface. Right inset shows the photograph of the channel. Micropillars are patterned inside the surface of the channel. To perform viral nucleic acid detection, we first chemically immobilized a single-strand DNA reporter on the surface of the micropillar and then injected both experimented required reagent and samples into the channel. To quantify the amount of bonded DNA, we used photoclavable reporters in the experiment. The photoclavable DNA was first immobilized and then released under UV illumination. We collected the released DNA and measured their fluorescence intensity. The higher fluorescence intensity, the more DNA immobilized inside the channel. Left figure shows our results. The blue box plot represents the intensity of collected bonded DNA probes on the planar surfaces. And the orange box plot represents the bonded probes on the micropillar. The results show that more molecular probes can be bound on the micropillar than the planar surfaces. We also performed the viral detection and attached our result on the right slide. It shows that the micro device can detect the target ranging from 0.1 nanomolar to 10 nanomolar. Thank you for your attention.